Hello, this is Project 3 for ECE 452 from UIC, and the goal for this project was to develop a robot in which is able to follow a wall indefinitely. So the plan for this was to have the robot come to a point that is near the wall, and then so it's able to detect it and then move around it. In this case, I selected the point -1 and 1, so right here where my mouse is, and then from there the robot will then start following the wall. So looking at the code here, a lot of it was provided by the professor, but we'll come down here to the main loop. So in the main loop, what we did is one thing that I changed from the provided code was I moved the define state within the main loop. There were some errors happening because of that. Next, I brought in the code from our previous project, project 2, in which we were supposed to go to a single point. So here we have this all set up, and where we have our values that we want to select. Within this while not loop, this is where we're going to have our main wall following set up. So here we're going to have three states. So we're going to go to state 0, and state 0 is just allowing the robot to detect the wall. So we want to get the robot there and then quickly change to state 1. So here we can see that here we're allowing the robot to spin around in circles until it is able to detect the quickest path to the point that I selected, in this case a diagonal path. And then here we have an else statement in which allows it to move towards that target distance at point 2. If that target distance difference is within 0.25, that is our desired state, and we want to change our state to 1. Once that is done, we will change to state 1, and then there's 8 different states that we have to kind of consider for this robot, because we have 3 different combinations of 3 sensors that we're using. We're using the front, front left, and front right. In this case, for state 1, any distance that is less than 1, which is a distance that I selected, from the front means that the linear speed of the device should go to 0, and that the device should start spinning around at negative 0.3 so I can locate its next trajectory. And the reason why is that the moment that the front distance increases above 1, this means that my robot is facing parallel with the wall, and I want to switch to state 2. And then state 2 is the actual wall following setup. So here, the first two are going to be my 2 wall following setups. So if our distance is above 1, but my left right region is above 1 as well, and my right region is below 1, which means the right side is within at least 1 of the wall, then I want to have the speed of my x linear movement to go to 0.2, and then my angular speed should be 0. So this means I start moving along with the wall. Now, if we have a state in which in front of me it's greater than 1, to the left of me is greater than 1, and to the right of me is greater than 1, I want the robot to stop and start rotating. And this is because there's a corner, and I want it to be able to go around the corner and then line itself up and keep going. And then I have all the cases for state 1 once again in case something happens in which for some reason the front does go within less than 1 of the wall. It can adjust itself for that. And that's really the whole program. So I'm going to close this, and I am going to run the program. And we're going to see the robot move around and go towards the desired point first. I'm going to make this a little bit larger for everyone here to see. Now This is not the most efficient way to program the program. I'm aware of that. Um, I'm just pretty inexperienced with programming, so um, this is very much, it works, but it is not optimal in the slightest. As you can see, it does sometimes spend more time spinning around in certain areas than I think it should, but it will eventually get to the point. As you can see here on the terminal side, also states what the current state is. So here it says traveling to, means it's traveling to the point, and then we should see once it gets within that range that we set, it should switch to um, uh, following wall or to whichever state that we selected. So as you can see, it's come within that 0.25 uh, uh, error that I'm allowing, and now it says wall detected, which is great. It's going to keep moving like this, and now it says follow the wall, so it's going to keep going forward and follow the wall parallel. Now we're going to see it come to this corner, and it's going to start rotating. Let me zoom out a bit in the space. And if we want to keep it within a certain range of the wall, that can be done by adding a range that is acceptable rather than just saying the distance. So in this case, it was 1. It says less than 1. So it varies here, but we can lock it into a certain distance if we want to do that. But in this case, it is uh, within a good enough accuracy to stay um, next to the wall without colliding into anything else or the wall. And as you can see, as it comes towards the wall and the distance in front of the robot drops below 1, it switches back to wall detected. It'll spin around and it'll start over to following the wall. And this is going to prevent it from crashing into uh, the wall. Right. Thank you for watching the video. I hope it was informative and have a nice day.